In this video, we're going to be talking about functions and when they are increasing, decreasing, and constant. And if you notice here, we say intervals of increasing, decreasing, and constant. So we're putting all of our answers in interval notation. All right, and one very important thing to note is that these intervals are going to be our x intervals. All right, those are x intervals when we label our intervals of increasing, decreasing, and constant. So let's go and take a look at the graph of a curve here. All right, so I've just graphed some random curve, labeled some points on here, and now we want to identify when is the graph increasing, decreasing, or constant. Well, a graph is increasing as we go left to right if it goes up. So again, we are always going to read the graph left to right, just the same way that you would read a book. Okay, so read left to right. All right, same exact way that you would read a book. So as I go left to right, if I'm going up, that means that I am increasing. So up means increasing, and that makes sense, right? That's exactly what we're used to. As I read it left to right, if my graph is going down, that tells me that it's decreasing. Decreasing, there we go. Let's see if my pen will write. And then if it is just a flat function, okay, like it is right here from 6 to 8, okay, if it's flat, then it is constant. All right. So now it is important to remember as we label these, okay, we are labeling it using x intervals. So I'm just going to write down here, let's put our increasing intervals here, our decreasing intervals below it, and let's just get our constant interval up here. All right. So let's just start with the constant one. It's only constant in one spot. Even though at -3, -1, it looks like it's starting to flatten out, it actually continues to increase. If it kind of curves as it continues to increase, then don't call it constant. We're just going to say that it keeps increasing through there. All right, so our only constant portion is this straight line right here from 6 to 8. You will be able to tell if it's constant. Because usually the graph will be constant for more than just like 1 second, and it will be a directly flat line. You'll be able to tell that it is a straight flat line. So it is constant here on the interval 6 to 8, okay, and again we are referring to those x values from 6 to 8. All right, and we are going to put brackets on each of those because those points are filled in. When we get into discontinuities at the beginning of next week, all right, then sometimes we might have parentheses in case there is a discontinuity. But for now, because those points are actually filled in, those points exist on the graph, we are using brackets to say it's constant from x equals 6 to x equals 8. All right, Nate, now taking a look at increasing. All right, let's read the graph from left to right. As I go left to right, when am I going up? Well, even though this arrow points down, right, that's pointed down to the left. So as I go to the right, it's going up here, it's going up here, it's going up all the way to x equals -3. However, on the other side of x equals -3, it continues to increase right through that point, all the way until I get to 1. So my increasing interval would be all the way from, well, what's all the way to the left? X equals -infinity, all the way until x equals 1. And I would include that 1. All right, I'm actually 100% going to run out of room. So let me just erase this, and I'm going to put it somewhere else. All right, let's do our intervals of increasing here. Again, all the way to the left, up until I get to x equals 1, I am increasing because as I go left to right, I'm going up. So from x equals -infinity to x equals 1, my function is increasing. Then I'll decrease from x equals 1 to x equals 3. Then I increase again. Remember interval notation, so I use my union sign. So then I'm increasing from x equals 3 to x equals 6. And then I'm increasing again from x equals 8 all the way for the rest of the graph, and that goes all the way until x equals infinity. So then I'm increasing from 8 to infinity. All right, so that's my increasing intervals there. And I only have one interval of decreasing. I'll just stick this in here. So my decreasing interval, that occurs from x equals 1 to x equals 3, because as I go left to right, my graph is going down from x equals 1 to x equals 3. So I'm decreasing from 1 to 3. And I have now identified my increasing intervals, my decreasing intervals, and my constant intervals. Let's just take a look and see how that relates with the mins and the maxes. Well, let's see, I have a relative max right here. I have a relative max here, I have a relative min here. And then because it goes constant at these 2 points, none of these points in here are relative extrema. They're not mins or maxes. All right, so we can see that we increase up to a maximum and then decrease. So for it to be a maximum, we need to increase up to it and then decrease beyond it. For a point to be a minimum, we need to decrease down to that point. So yep, we're decreasing to 3, and then we increase from 3. All right, so again, we increase up to a maximum and then decrease. For a minimum, we decrease down to the minimum and then increase. All right, so again, I hope this video helped. We'll have some homework where we are identifying intervals of increasing and decreasing, as well as continuing to identify extrema.